Independence. Two events are considered to be independent if they do not affect one another. So knowing the outcome of the first event will not affect the outcome for the second event. So when we talk about independence in words, this is what our definition looks like. The first event does not affect the outcome of the second. Okay, so if we think about flipping a coin, when we flip a coin, let's say I flip the coin 10 times, and all 10 times it came up heads. So I got 10 heads in a row. When I go to flip it the 11th time, what's the probability that I get a tail that time? 50%. Why didn't it get better? If I had 10 heads in a row, why am I not more likely to get a tails this time? Yeah, because the coin can't determine what it comes up as, right? So if a coin flip are independent events, every time I flip that coin, I have a 50-50 shot of getting heads or tails. So it doesn't matter. I could have 100 heads in a row. I am no more likely to get tails on that 101st flip than I was the first time I flipped. Okay? So it's always 50%. That's what we mean when we say independent. So knowing the outcome of one does not affect the other, which means dependent events do affect each other. So if two events are dependent, that means knowing one has happened will affect the outcome of the other. Okay. So some events are fairly easy to determine whether they're dependent or independent. But it might not always be very intuitive. We talked about flipping a coin. We know that if I flip a coin, I pick the coin up and flip it again, and then I do the same thing over and over, every time I have a 50% chance. That coin can't determine how it's going to come up heads or tails. Rolling a die. If I roll a die, I pick it up and roll it again. Each time I roll it, each probability stays the same because those events are going to be independent of one another. But there will be scenarios where you might be dealing with other topics that might not be as intuitive, whether two things are independent or not. So we're going to talk about a way to determine independence based on probabilities. So let's say our two events are selecting a king and then selecting a queen with replacement. So I'm going to draw two cards. And I want to know if selecting a king and then selecting a queen with replacement, if those two events are independent or dependent. So knowing that I selected a king first, is that going to change the probability that I select a queen on my second card? That's the goal here. So when we want to evaluate this, we've got to think about what is my probability for selecting a queen in general? 4 out of 52, right? So if I'm going to select a queen just in general, it's going to be 4 out of 52. Now what I want to know is, if I select a king and replace it in the deck, does that affect the probability of getting a queen? So when we think about that second scenario, I select my king, so I know I drew my king, place it back in the deck and shuffle. Knowing that I drew a king first, what's now my probability of selecting a queen? Still 4 out of 52. So regardless of what I do that first time, since I replaced the card, my probability for selecting a queen second is still the same. I still have a 4 out of 52 chance of selecting. So what this leads us to is the fact that drawing a card and then replacing it and doing that over and over will generate independent events. Because I'm replacing, I'm always going to be out of 52, which means it doesn't matter what's happened before, I always have the same chance of drawing whatever I'm looking for next. So this would be independent events. Now if we look at this a little bit different way, if I select a king and then a queen without replacement, Okay, so the queen is my second event, and here's where people make mistakes a lot of times when they're trying to determine independence. Now, you can do it a couple different ways, and we'll talk about that here in a second, but we're looking at selecting a queen after knowing we selected a king. So there's a definite order to our events. So when we're looking at drawing the queen, again, we have to establish the probability of selecting a queen normally. If I was just looking at a standard deck of cards, what's my probability of selecting a queen? Okay, so it's 4 out of 52 still. Now, what I'm doing here is I'm throwing in a condition. This time, I'm saying I'm going to take a card from the deck. It's a king. So I take a king out of the deck, and this time I keep it. I do not replace it. So if I do that, what happens to the probability of drawing a queen in that instance? It becomes 4 out of 51. I removed one of the possible cards from the deck. So now, when I go to draw my second card, I still have 4 queens in the deck, but now I only have 51 cards left to choose from. So my probability changes. So selecting a queen had the probability of 4 out of 52 if I was just doing it normally. But if I select a king and remove it from the deck, now the probability of selecting a queen is 4 out of 51. So selecting that king and removing it from the deck changed the outcome. It changed the probability that I could draw a queen. So these would be dependent events. Drawing that king this time did affect what happened with drawing my queen. Is everyone okay with that? Okay. Let's take a look at another example. So the 2 events, tossing a coin and getting heads, rolling a 6-sided die, and obtaining a 6. So I'm going to flip my coin first, and then I'm going to roll my die. Okay? So we want to know if these 2 events are independent of one another. So what I need to look at first, rolling my die is my second event. So I need to look at, if I just roll the die alone, what's the probability of rolling a 6? 1 out of 6. Okay, so if I were doing this just alone, rolling the die, I'd have a 1 in 6 chance. But now, if I throw in my coin toss, so now if I say, okay, I'm going to flip a coin and then roll my die, what's going to be the probability of rolling a 6 in that scenario? 1/6. Why? Yeah, because the coin has no effect on what the die comes up. Okay? So these would be independent events. The probability stays the same regardless of that condition of flipping a coin first. Okay? So this leads us to our formal definition for independence, and you need to understand and know this formal definition. It is going to be extremely important here. So, formal definition. Events A and B are independent, and this is not a misspelling. This IFF notation means if and only if. So the only way 2 events can be independent is if the probability of the first event is the same as the probability of that event given something else that's happened. So A and B will be independent if and only if the probability of A is the same as the probability of A given B. Okay. In notation, which again is going to be extremely important, you guys have to understand notation and know how it's utilized, know how to translate between math and English. So what this statement boils down to, the probability of A has to be equal to the probability of A given B. Now, one thing to note here. So this is saying A and B are independent if this holds true. Okay? Could I do the same idea, but use probability of B instead? So instead of finding the probability of B alone, and then find the probability of B, or A given B, can I do probability of B alone, and the probability of B given A? Would this result in the same conclusion? Yeah. It doesn't matter what order you go in, as long as the probability of one event alone is the exact same as the probability of that event given another event has happened, you're going to be proving your independence. Okay? So one of the things to note here, when you have your two events, what's going to happen is they're going to say, here are your two events, determine if they're independent. So when you look at it, you want to determine, is event A or event B easier to calculate as far as probability? Whatever one's easiest to calculate alone, go ahead and choose that one as your lone probability. But then you need to make sure you calculate that probability again with the condition that the other event has happened. So when they ask if two events are independent or dependent, you have to show me that you have checked that this equation holds. The probability of one event alone is equal to the probability of that event given that the second has occurred. If I don't see this information, you get no credit. On homework, you get no credit on a quiz or on a test. If you don't show me that those probabilities are identical, it doesn't count. Now, if you calculate these probabilities and they're different even by a little bit, you would have to say that the two events are probably not independent. All right? Now, in some cases, there might be some issues with like random sampling. So based on random sampling, they give you some values to calculate probabilities. In those particular instances, because random sampling was involved, remember there is some sampling variability. So if we were to calculate our probabilities based on that, they may differ slightly, and we might still be able to say that the events are independent of one another, because we have that variability to account for there. So in some cases, you might get just a slight bit of difference between the two values, which means you could still conclude that they might be independent. But for the most part, what you need to be able to show is that they are identical. If they're not, if there's any sort of difference, you would say that they're dependent based on this rule. Okay? That's it. Now, the fact that this was a short lesson does not mean that it's not an important one. You guys do need to understand how to use this rule correctly. So with the remaining time, you need to be working on the following problems on page 336. If you also want to work on the page 333 and get that quite finished, that's fine. But I don't want to see phones. I don't want to see other homework. I don't want to see anything else other than stats going on right now. Okay? So you are working on one of those two assignments or working on previous assignments, whatever. I would prefer you work on this one. But you need to be working. If you want to work with partners, you can. But if you're not going to be working, I'm going to split you up and you're going to work on your own. So you guys need to use this time effectively. The quiz is on Tuesday, which means all of your homework assignments for Chapter 5 must be turned in Monday at the latest. If I do not get your assignments by Monday, you will not be allowed notes on the quiz. So that's another reason you need to use this time right now to work on finishing up the homework here. So go ahead and get to work. If you have questions, make sure you ask.
What if assignment due for
No, just Chapter 5 stuff.
Yeah, I have a question about page 229 from last chapter. I can't find out. I'll look at these. So there's one-
Yeah, they only let us put so many numbers in on the Sims program. Let's see. Alright, so you got 2 through 8 even. 12, 21, 24 through 28 even. And 34 through 42. Yep.